too much time, and I was just going to show you the basic functions that I use, and then I thought it would be better to kind of see how it works instead of just going through slides to see, just the mechanics of it. So first I'll share my screen and can everybody see the screen?
No, oh yeah, we can see it.
Okay, so this should be, you should see SolidWorks. And then if you can't hear me or if I'm going too fast, please let me know. I have the chat open and I'll try to keep my ears open also. So if you have any questions or if I'm going too fast, too slow, please let me know. So this is an isokinetic probe that we used in our aerosol lab. So this is from the side, and then if you see from the top, you can see that it's a cone shape, and then it has a hole in the middle. And then this is actually a 3-part design. So if you see on the left here, there's going to be probe part 1, probe part 2, probe part 3. So you see from the front again, it can be divided into 3 parts. So if I drag this part up, this is the top part, this is the middle part, and then this is the third part. But if I zoom in a bit, this I made it into a thread. So if you see the insides here, you can see the threads inside. So what I made was to rotate with the thread. So if I, for example, the bottom part looks like this. So if I rotate this, it'll come out. It doesn't, I can't pull it like I did the top part, but this one, if I rotate it, it rotates with the thread, then it comes down. So this is the third part of the probe. So this is one of the models that I created recently using SolidWorks. So this is all possible, and then so much more in SolidWorks. So you can see all the threads here. So this is one of the designs I did with SolidWorks, and then another one was this. Can you see this one? So this is a meat facility, and you see from the top view. So these are the different rooms, and I was trying to see how airflow with the HVAC system, the air conditioning systems, travels through the different parts of the facility. And this, I made it in SolidWorks, but I moved it into ANSYS to do a computational modeling of it. So there are several openings in between that air can move through. And then if you put the right parameters and the inlets and outlet conditions, boundary conditions, everything, you can see how air can move through this whole facility. Of course, it's going to take a lot of computational power and a lot of time, as the facility is quite big. But in smaller facilities, small equipments, it shouldn't take that long of a time. So these are just some of the options some of these things I designed using SolidWorks, and then I'm just going to go through briefly how you can do different, how you can create different things. So first, so in order to make it, so what I was thinking today was to go over this probe here. I was trying to create a simplified version of this probe to use different functions in SolidWorks to design. I think we might have only time for the top part and the bottom part. So we're not going to go through all the threadings and all the little details, but I'll just show you just the brief details of how to use SolidWorks. And I think it may be applicable to AutoFusion or any other software you use. So first of all, you click on the new, on the top, you'll see a tab called new. If you click on this, tab will show up saying SolidWorks document, and it'll have a part, assembly, and drawing. You want to first start off with part, so you'll click on part, and you'll click on OK, and then a new blank page will come up. I believe SolidWorks is available in the software.tamu.edu, and then right now I'm using a 2019-2020 version, but I believe the newest edition, the 2020 to 2021, came up in software.tamu.edu. And then if you open up the part, it'll have just a blank area with nothing in it, just in XYZ coordinate and just different options. If you see here on the left, you'll see a tab, then you'll see a front plane, a top plane, and a right plane, and an origin. And then if you want to see all of it at once, there's an eye icon here. If you click on it, it'll have different options to see. And then if you click on this one, it says hide show primary planes, and you'll be able to see all these three major planes. So if you want to make it more visible, right now I just need just one plane. So, and then in this top area here, this one in the middle, it says view orientation. This lets you see the model in the middle at different size. So you can see it from the top, the right, bottom, or isometric. If you click here, it'll be an isometric view. Right now, I don't have anything, so it doesn't show anything, but this is just the different view options. And then this one is, you can see it at a solid shape or like a wireframe, like I showed you before, but we'll go through them one by one. So first of all, I want to create this one. I'll start off by creating the part in the middle. Second part, this is, I believe, more simpler to start with, so I'll just show you how to create this part first. So what it is, so what this is by its own is, just open it up real quick. So this is the part by itself. It's just a bowl-shaped part with a hole in the middle, and then threads on the side, but we're not gonna go over the threads today. So it's just a cylinder with a hole in the middle and another hole through the bottom. So we'll be creating this from scratch. So how you do it is there are different ways to create a cylinder. So one of the easier way would be to go into the top plane. And then if you right click on it, an option will come out. And then if you click this one, it's called sketch. If you click on it, it automatically put the top plane in front of you. And then you also see the origin point. And then you'll see the tab has switched from feature to sketch. And then it'll have an exit sketch sign. So it means that you are in sketch mode. So to create a cylinder is quite simple. It's just one of the ways you can do it. One of the simpler ways you can do it is to click on circle. There are line options, there are rectangle options, there are arc options, ellipse options, but we're gonna go with circle right now. If you click on circle, it'll be highlighted, and then you'll see a circle tab show up on the left. And then an easier way to do it is to click on origin to indicate your origin point. And then if you click on it, you'll see that a circle shows up, and then you can change diameters however you want. And then if you click anywhere, it'll create a circle, and then it'll show the different parameters like the radius here. And so this is a circle, and then I understand this may be basic for some of you, but I'll just go through and then just go to different options as I go. And then you'll see an icon that says it's underdefined. So it'll appear in blue. And then if I want to create other circles, I can just click on another point and make a new circle, and then it'll just keep creating circles. But for now, I just need one circle. And then you'll see an icon that says it's underdefined. What it means that this circle is not defined yet. So if you move it around, if I click on it and if I drag it, it'll change. So it's not properly defined. So it'll keep changing if I accidentally mess around with it. So what you can do to define it is go to Smart Dimension. And if you click on it, this icon will show up next to the mouse. And if I click on this circle, it'll let me know, ask me what kind of diameter I want from this. So if I click on it, it'll have the current diameter, which is set to 4.045. But say I want it to be 4 inches. So I'll click on 4. I'll click the check mark. And then it'll give me a 4-inch diameter circle. And then you'll see that the color has turned black. So it means that it is now defined. And if I exit Smart Dimension, then if I click on the circle, you'll see that it has changed to fully defined. This is what you want most of the case, because now if I try to drag it, the diameter won't change. So this is fully defined. So this is what you want. And also about the units, there's on the top, there's an options menu, options tab. If you click on the options menu, the systems options general box will come out. Then if you go to a tab called document properties, you'll see a tab here called units. If you go under units, you'll have an option to change the units. So right now it's set to IPS, inch, pound, and second. But if you want SI units, there's a meter, kilogram, second, or centimeter, gram, second. So depending on your models and team and then the specification, you can change it to different options. It will automatically change all the measurements and then future measurements according to the unit system. But right now we'll just go with the IPS. So right now you have created a circle. So how to make it in? So if you kind of rotate it, you'll see that in a 2D plane that we set on the top plane, it'll just be a circle on the top plane. So if you want to make it into a cylinder, you'll go to the feature tab on the left here. And then there is an option called extrude boss base. If you click on this one, this icon will show up, and then on the left called boss extrude. And then you'll see that this also changed. So you can see this yellow part and then an arrow that showed up. And then you can see there is some thickness to the cylinder. So it has a cylinder shape now, and then it has an arrow in the middle. What the arrow indicates is the direction of the extrusion. So if I click under the direction 1, if I click on this arrow button, it'll reverse the direction. So if I wanted to point downwards, it'll change directions. And then the length of it is right now set to 0.1 inches by default, but I can change it to however I want. And then there are different options to do it, right? Like blind, up to vertex, up to surface. But blind, if you set it to blind, it'll just extrude it to a set amount that I designated to. So if I first wanted to do a 2-inch, you'll see that the cylinder goes up. So it extrudes now by 2 inches. So right now I wanted to set it at 2 inches, so I'll just click on the check mark. Then you'll see that the circle has now become a cylinder in this plane. And I'm going to now make a hole in the middle and then another hole in the edge, so to make it to the probe part. So I'll go to the bottom. Actually, I'll go to the top side of it. And then if you want to cut it, you can, there are different options, but simpler way, I guess, is to click on the top surface. So if you rotate it, you'll see that only the top of the cylinder is selected. If you click on the side, only the side will be. And then right now I want to extrude the top part. So if I click on top and then go to top view, I can right click on the surface and then it'll show different options. Right now I want to click on sketch. So there's an edit sketch also if you want to edit the option, but right now I'm going to make a new sketch on this. And then so like it happened for the top plane before, it'll now designate this surface as my plane where I can sketch. And if I sketch another circle, point at the origin, and draw it out. And now you can see it's still underdefined, so I can go to Smart Dimension, define it again. Right now, I'm going to define this to be a diameter of 3 inches. Then you'll see that it automatically adjusts this. And another option of SolidWorks is that it doesn't let you over-define. So for example, what I mean by it, so so you can see that this is already fully defined. If I try to set the distance between this circle and this circle, it'll tell me that it is already defined, so I cannot do this definition. I can't define this distance because this is already set to 4 and then this is already set to 3. So we know that the distance between is going to be 0.5 inch. But if I try to define it, it will give me an error saying that this is already defined, that this definition will over-define it. So it's just another option of SolidWorks. And then if I exit Smart Dimension, you'll see on the left that this tab popped up from before because I created a sketch and then I created a boss extrude. And then another sketch that I'm creating right now is shown here. And now what I created is the cylinder and a circle drawing on the top. And now I go to features again. And then instead of going to extrude boss, now I'm going to go to extruded cut. So what this does is it's going to cut it. It's going to extrude it in the surface. So you can see that it shows a hole in the middle, also shown in yellowish color. And right now I set to blind, and then set at 2 inches because I defined it before. And there are different options to do it, and up to surface is one of it, but we're going to go as blind again. And right now I'm going to set it to 1.5 because I don't want it to go all the way back, all the way to the opposite end, but just through a certain distance. So you'll see if I click on the orientation and go to front view, you'll see that it doesn't go all the way down 2 inches, but only 1.5 inch. If I click on the check mark, you'll see that in the top, it has created a cut and it doesn't go all the way. So this side is blocked. And if you see it, look at it from the bottom, you'll see that there is no hole. It's just a flat surface here. And then what I want to do now is again, cut another smaller hole from the one I cut in a smaller circle. And then you'll see on the side here also, there was a first extrude and then a second extrude cut, then the 2 sketches. So you can keep track of what you have in this part. So I'm going to click on this surface again. I'm going to click on sketch. Then you can go to the orientation and top view to make it more clear. I'll create another circle starting from the origin. If you accidentally make it out of the origin, then create a circle like this. There is an option to direct this to the origin. You can click on the center point of the circle. You can, at least for Windows, you can click on Control and then click on this point as well. So you have the point of the circle and then the origin. And then there's going to be a properties tab that comes up in the left. And then you'll be able to select the relationship between the 2 points. So if I make it, there's an option called coincident. If I click on this one, you'll see that the circle moved so that the center points are coincident with the origin. So this is a useful option to know. And still it's underdefined, so I'm going to define this circle to be, the circle will be 2.5 inch. The diameter will be 2.5 inch. And so you can see that the circle is created in the middle. and then I'll exit Smart Dimension, and then go to Features again, go to Extrusive Cut. And now I have two different options I can do. I can either click on blind and set it to be 0.5 inches, or I can go to up to surface, and then I can click on the bottom surface here in the face dash plane option, and then it'll automatically set the circle here to extrude cut until this surface. It won't go below it. So if I click OK, you'll see that there's a hole has been created in the middle, in the bottom. Then the top, you can see there's the outer ring, but in the bottom, you can only see just a ring. So this is the simplified version of this part. Do you have any questions until now?
That's great, Joseph. Yeah, let's take a break here for some questions. What students, I want you to, I know it's going to be hard to follow along here when you're not doing it yourself, but keep in mind what we're creating here is a recording that you can go back to. We'll post this on our eCampus site. So when you pull up SolidWorks, you can replay this and follow along with Joseph as he's taking you step by step with how to create a drawing like this. So you'll be able to learn SolidWorks by practicing this over again. But let me open it up. Who's got any questions? I've got one. How do you rotate the drawing again? Show us how you rotate it.
The rotating, for me, I have in my mouse, I have a middle button, like what the button that I scroll with. If I click on the middle button and then I move my mouse, then it rotates it for me. So I believe it may be different for, but if you have like a middle button in the mouse, you can click on the mouse and the middle button, and then if you move your mouse, it'll rotate it with you.
And it rotates in the direction where you have the cursor, right? You can rotate it left or right, or
yes,
right or left. Okay.
Rotate it up or down, left and right. And then if you scroll with your mouse, it'll zoom in and zoom out also.
So a lot of that you're doing using your mouse with a right click or a middle button.
Yes.
Okay. Any other questions?
Say you wanted to change the defined size of one of those circles, how would you do that?
So if you want to change, if you have already defined it and you realize that you made a mistake, and if you want to change it again, you can go to sketch. For example, if you messed up with, if you have a wrong dimension in the sketch, you can right click on sketch, and then there will be an edit sketch option. And then it'll show you, if you go to the top plane, it'll show you the original sketch you started off with, and then you can click, double click on this dimension here. And then this tab will show up called modify. And then you can change it to however you want. And then you see this thread here. It's kind of just a fun option. You can just turn this thread and it'll kind of dial it up and down by some increments. But yeah, you can change it here. The same goes with extrude. If you exit sketch, if you realize that you want to extrude it more or less, you can right click on the boss extrude, and then there will be an edit feature. And then also here, you'll see an option to change the option or the distance that you want to extrude it.
I have a question. So is there any undo function or any like a trace back saying you've done 10 steps and you figure out the past 10 steps is like totally messed up, you want to go back to like roll back and redo it again? Is there any function like that?
Yes, like in any like Microsoft Word or anything, there's if you press on Control Z, it'll go back, but also in the top, you'll see an undo button, which is a Control Z is the short key. But if you press on this arrow button here, it will show you the recent changes that I made. It only shows up till 2 right now, but as the more you do it, and then the more you do it, the more will show up, and then you can go back as many steps as you want, as you need.
I see. And one of our student, Marcelo, he has a question is that, can you change the material of the objects just to get the property like tensor or stress on this property or something like that?
Yes, I know there's an option to do it. So if you, I think, oh yeah, here. In the right and the left here, there's an option called material. If I click on, I can double click on it, or right click on it and go to, sorry, edit material. And then there are different options available in SolidWorks. Steel, iron, aluminum, copper, titanium, zinc, and plastics, rubber, wood. So yes, there are different options that you can use to identify it or to change it into anything that you need to get the material properties. It'll show up everything here, like the shear modulus, tensile strengths, elastic modulus. So yes, and then also if you change it to, for example, carbon sheet steel and apply, I believe it'll also change the appearance of it. Yes, so it changes color to indicate that this has been selected.
Okay, thank you. That answers my question.
I also have a question. Is there a way to where you can, like, say you've been doing all these dimensions and stuff in inches, and you realize, oh, I've been doing this in inches, I need to change all these to like millimeters? Is there a way to like just change it like universally, like all at once, or do you have to go through every object and change it?
So for example, now we have made 3 sketches and then 3 features in all inches. And if I go into options, and then I go to document properties, and then go under units. And then if I click on, for example, the SI units, meter, kilogram, second, I click on the MKS, and then I click on OK. You'll see it's still the same model, but if you click on the sketch now, you'll see that it has changed from 4 inches to 0.1061 meters. And also with the box extrude, you'll see that the dimension has changed to 0.05. So it automatically will change it for you. Every option that you have currently set will change from the IPS to the MKS automatically. I don't think there's an option to do both IPS and MKS, but what you have will all be changed to the unit that you set here. Any other questions?
Okay, why don't you press on with your tutorial? This is really good.
Right, thank you. So, and then SolidWorks is really good and powerful, but it also is very, I guess, computationally consuming. So it's always good to save in between, because in the previous version, it was known to crash quite a lot. So always save your materials and designs. So click on the save button. I'll just make another folder out here. So, SolidWorks. And I'll just set this to be part 1. So this is set to part 1. And now I'm going to make another part of it. I'll click on new again. I can leave this open and I can just go to parts, go to new. And then again, I'll click on the parts option. And then I believe we might have time, but I'll go through the assembly also because that might also be useful. So another blank page pops up with name part 3. Same, you can see the front, top, and right plane. So right now, I want to create this part. What it is like a cone shaped model with a ring on the side. So you can also go to a cylinder mode and then extrude all the way and then cut it down. But it is a bit more complicated because it's a cone shape, not a cylinder anymore. So it'll be more difficult to cut it. So I'll show you another option to create this kind of shape, even with a cylinder also. So instead of going to the top plane now, you'll go to the front plane and you'll click on sketch. And what you'll do now, I have the dimensions all written down, so I'll just go over it quickly. So how it looks like is this. So I'm gonna select line, the line options, and then to make the defining process more simple, if I start from the origin and go to the right, you can see there's a dashed line that pops up. It shows that my point right now is going to be horizontal with the origin, so it makes it easier to define it. If I make it somewhere in the outside here, it's going I'll have to define the position of that point also. But if I make it along the origin, it's going to make it along the x-axis, so it's going to be easier to define it at the later on. So if I click on it, it'll show that this blue line pops up, and then how the cylinder looks is kind of like this. So, and then also if you click on it, another line will show up from the point that you ended, and then if you go 90 degrees, it'll also kind of lock on, so that it is easier to define it later on. Again, if I go to the right, click on it, it'll stop this line and it'll start a new line. And then how you define it doesn't really matter because at the end you'll have to use smart dimension to define it. But close to accurate as you can make it, it'll be easier to visualize it. And then it'll make a cone. And then I'll come back to this area. And then once you created this outline, it'll automatically end the line, so the line won't show up anymore. But if I make a new line, it'll make a new line from wherever I start. This is not what I want right now, so I'll delete this. And then as you can see, all the lines are in blue except this line, which means that if I move this line up and down, it won't do it because it is defined at the horizontal line. But if I move any other point, you'll see that this messes up all the design because this is not fully defined yet. So right now the dimensions I have are, as I might be running out of time, I'll just quickly set the dimensions to 0.25 inches using smart dimension. And then you'll see that all the other parts will be locking on accordingly. It'll be more defined as I go. This will be 0.25 also. So this is what I have defined until now. And then I'm going to create another line starting from the origin and towards the top, just the straight line and the vertical, the y-axis. And then if I want to just make one line and then I don't need this secondary line, I can click on escape. And it'll delete that line and then just leave this line. And then I'm going to define the distance from the very edge of the cylinder, to this line, which is going to be my axis of rotation. So what I'm going to do is I'm going to create this model and then rotate it along this line. I'm going to make this to be 2 inches. Then you'll see that it goes out of the frame, so you can zoom out to see the whole view. And then you can also, from what I did now is I defined just a single line, but you can also do it a relationship between a line and a line, like I did here, or a point and a line also. If I just define this point, there's nothing to define, so nothing shows up. But if I click on this point and this line, it'll show up a unit dimension. So I'll set this to be 4 inch. Then you'll see this also goes out of the frame. If you zoom out of here, you'll see that the point goes up. But still, this lines are colored in blue, because if I move this point around, it doesn't have an angle set. So it's going to be always 4 inches away from the line, but it is free to move around in any direction. So another way you can do it is to click on Smart Dimension, click on 2 lines that are coincident, that are touching each other, and then if I click on this line and this line, Smart Dimension, click on this line and this line, it'll show up an angle. So you can also define the angle between 2 lines that are coincident. And then I can define this to be, let's say, 110 degrees. Then you'll see that this goes all the way out here because it's not fully defined here yet. So I can move this line. Oh, it's not. Yeah, I can move this line to the left if I want to bring it inside. And then now I'll define this point, this line here, so that it doesn't go to the other side. I'll set this line to be 0.35 inches. And now all the parts are defined, so everything will appear in black. And then if I try to move any point now, or any line, it won't be able to move because it's all fixed. And so this doesn't look like a cylinder, but in order to make it into a cylinder, we have this model. Then we have the line here. So we're gonna go to features now. Sorry. And then we're gonna click on there's gonna be an option called Revolve Boss Base. And we'll click on this one. What this will do is it's gonna ask for an axis of rotation, which is gonna be the line that we created here. So you click on this box here, and then you click on this line, and it'll show that line 8, which is this line, shows up here. And then you're gonna select the contour. Then you'll click on this model here, and then this will turn up in red. So if you click on it, it'll give you a direction here, and then this is the direction you want. So if you click on OK, oh, this is, I guess, too far away. So I'll just set this to 3 inches. And then I'll go back to revolve base. Set the axis of rotation again. Select the contour. And then if you misclick something, if you, for example, I clicked on the line 1, you can click on that option and then you can click delete. Then it'll delete it for you. So I have the line as the axis of revolution and then the contour. And if I click on OK, okay, so the thin feature was selected, so I guess by default, so you can remove that and then click on axis of revolution again, and then select the contour as this, and then it'll show up a preview. It'll give you a preview of what it's going to look like if you click on OK. This will be the cylinder shape that is similar to what I had. It'll show you a cone in the middle and then a ring on the sides. And then always remember to save. And this is the last part I want to show you, which is the assembly part. Save this as part 2.
Hey, Joseph, before you go to that, anybody need to see that again, how he turned that into a cylinder? Why don't you go through that step one more time?
Okay.
I missed it.
Yeah, sorry, there was an error that showed up, so I'll go through it again. So I'll just delete the revolution. So you have this on the front plane. This is you'll click on the edit sketch. So this is the sketch that I had beginning. And then I go to features and I go to revolve boss base. And then this option will show up. And then I don't know why, but the thin feature, I guess is by default is clicked. So uncheck this option called thin feature. And then in the axis of revolution, you click on this line that we select. It doesn't have to be, it doesn't have to go all the way to cover the model. It just have to be a line. It doesn't need to show up here. So on the axis of revolution, you'll click on this line and it'll show up line 8. And then for the contour, you can click on the contour that you created. And then because this direction is set to be at this direction, 360 degrees, it's going to go all the way around. If you want to, maybe if you want a circle, a half circle or half a cylinder or just a cut view of it, you can select this to be 180. And then this will just extrude it just halfway through it, as you can see here. But because I want it to be going all the way around, I'll select this to be 360. Then this will give me a full cone model. Then I'll click OK. Then this will give me the whole model.
Thank you. That was good.
Do you have any other questions before we move on to the last part?
So if you wanted it to be a solid, like all the way through, like not hollow, how would you do that?
Okay, if you want to make it a solid and nothing in the middle, you see the front sketch that I created, you can see there is some distance between the axis of rotation and the model that I created. So if you make the model, for example, if you create a rectangle and you start from the origin, and then go to like certain distance, and then you rotate it, then there will be no hole. It'll be just this this model that started off with the along the axis of rotation, and it'll rotate around the axis. So it'll just create a solid without any holes inside. So it's good. It's the key is to make no space in between the axis of rotation and the model. Okay, then I will go to the assembly, and then if you have questions on the way, please don't hesitate to stop me and ask me. And so we created, so we'll go to new again. And then right now we created 2 part models, but now we're going to go to the assembly version, assembly option, and then we'll click on OK. So what this does is we created 2 parts, but we wanted it to be in the same page. So we want it to be together because this is the whole model. So what we're going to do here is this new page will pop up and it'll say assembly 1. And then on the left, it'll have an option called begin assembly. And then this is all the options that all the documents, SolidWorks documents that I've opened. So right now we want to import part 1 and part 2. So if I click on part 1, it'll highlight this. And if I move my mouse to the center, it'll bring this part with me. And then it'll ask me where do you want to place it. But I'll put in part 2 first, the one we just created. Then I'll put it somewhere anywhere along the middle. And it'll show up an assembly version here. And it'll tell me that part 2 is placed in the option. And then if you go to the assembly tab on the top left, you'll see an option called insert components. So I just inserted one component of it, and then I want to insert this component also. So you'll see that you can see the 2 models, 2 parts. And then I want the this part, the part 1 that we created earlier, to cover the cone on the top. So in order for me to do that, I have to rotate this 180 degrees. So if I right click on this before I left click, if I right click on it, or there's this option in the middle too, to rotate it. So if I click on the rotate component about X, it's going to rotate it along the X axis. Or I can just right click on it and it'll have an option for rotate about the X. So if I say rotate about the X, it'll rotate it along the X axis. So you can, it's a useful feature to have it so that you can input it in the way you want it. So this is how I want this to go in. So I'll left click it now to import this part. And then you'll see that there are 2 parts in this 3-dimensional plane, 3-dimensional space. And what I want to do now is to put this cover on top of this cone like this. And then we know that this diameter is 4 inches and this diameter is 4 inches, so this will go right on top of it. But if you try to do it with your mouse, you'll see that it doesn't go all the way in. So if you see it from the front plane, it kind of looks done right now. But if you see it from the side, you'll see that it is overlapping and is not really correct. So if you do it again here, then you go to an isometric view. You said it kind of does the trick also, but if you move it around, it doesn't all connect it automatically. So there is an option to do it. In the left, you'll see the part 1, and then the part 2 that I imported and then created. And then you'll see a letter called F, a parenthesis F, and a parenthesis hyphen. What this means is the F means it's fixed on this plane. So if I try to move this part around, because this has a dash or a hyphen, it can move around freely, but the F means it's fixed. So if I try to move this part around, it won't. If I try to drag it all the way across the screen, it's just fixed, and then it'll show me a message saying that the selected component is fixed, it cannot be moved. How you can fix it or unfix it is to right click on this part, and there's going to be under component 2, there's going to be an option called float. If I make this to float, you'll see that this changes to hyphen, and then now I can move it around the screen. But I want at least one of them to be fixed in this plane, because you can't, in this plane, you can't adjust it necessarily to the origin. So you're going to have to make one part fixed. So you're going to right click on this part, and then you'll see that the float has changed to fix now. So if you click on fix, you'll see that this now changes to an F. And you can also change this part to be fixed, but then you can't really assemble this. So it's better to leave just one part fixed and then make the other one move relative to this fixed one. How you do it is this option called mate. So this mate, if you click on the mate option, it's like a clip, paper clip. It'll ask for you to click on mate selection. So it needs at least 2 surfaces, faces, or lines to make it. So for example, if I click on in this option, I want this outer ring to go on top of this ring here. In order to do it, I can either click on this face, this line. So it gives you different options. Delete this. And for example, I'm going to show you one way to do it. So I can click on this line, and it'll show me edge of part 1. And then I can click on this edge here on the other part. And then you can see that this part moves automatically because it assumes that you're going to coincident it. You're going to coincident this part, which is what we want. But I'm going to show you a different option. So there's another option called concentric. And then what this does is it makes the, then if I'll click on OK first. And then what this does is it now locks these 2 edges in the same location. So all I can do now is move this up and down. I can't move it right and left, but now this is going to be on the same axis in the same y axis. So I can move it up and down. And it's hard to see right here, but this upper part also rotates. If I move this, if I turn this like this, right, I showed it earlier, it rotates, but it only can go up and down. If you don't want it to rotate, you can go to the Mates tab here, right click on it, go to Edit Feature, and then under the concentric option, there's an option called Lock Rotation. Now all it's going to do, if I click on OK, now all it's going to do is go up and down without any rotation. And then I could have just started off with just mating this part and this part, but I just wanted to show different options under mate that you can use. Another option you can do is if you want to lock it down so that it goes here, like I showed you before, you can go to mate. Not this face, but you can also click on the faces, like the bottom face here, and then the top face here. And then this only will make sense to coincident it. So if I click on OK, now it'll be coincident, it'll be stuck here, so nothing will be able to be moved right now. And then you can see that the hyphen mark disappeared from the left, which means that it is fully defined. Also, another useful option that you can use is if you right click on it and you decide that you want to move this part a bit up and then you want to see what's in between, there's an option called suppress. It'll be like a box going into a transparent option. If you click on suppress, it'll make this a bit transparent, and then it'll remove this option. So it is still there, but it's not deleted, but it's just suppressed. So it means that it is not in effect. So you can move this up and down again to see what you have inside, if you want to see it. And then if you realize that, oh, you have done what you wanted to do, you can right click on it, and then you can click on unsuppress, and then it'll bring it back to the original state. And if you realize that you made a mistake and you want to change the option, like you did with the extrude or sketches, you can right click on it and then go to edit feature. And then it'll show you back to this page, and then you can change it however you want. And right now to leave it as it is. And then for the last, I guess, function that I can show you is you can go to a front page view of it. And then this will be the front view of the model that we created. And then if you click on this side, this option, which is a display style, and then you go to a wireframe, it'll show you what's inside of it. So it'll show you all the edges. So for example, in this one, you'll see that the cone is overlapping with the part one here. So you can see that the cone is outside, is intruding with the one of the parts that we created. So one of the bad things about SolidWorks, it doesn't like consider this also. It doesn't consider this option. It'll just overlap it. So if you're not careful, it might be an error. So it won't show up as an error, but it wouldn't be accurate. So you'll have to always make sure that if something is inside something, you'll always have to make sure that the dimensions are correct. And then you can right click on it, because this is an assembly. You can right click on it, and then there'll be an option to open part. And if you click on this, it'll direct you back to the part page. And then you'll be able to adjust the sketches there. And then if you adjust the sketch there, it'll also adjust this assembly mode here. So it'll automatically do it for you. It'll take some time to update it, but this is how you can go back and forth with the part and assembly model of it. So this is just a quick, brief overview, and I believe I was going very fast for some of you, but the recording will be available, I guess. So if you have any questions or if you get confused with parts, you can always look back then. And there are lots and lots and lots of really helpful YouTube videos or helpful materials outside and all the different parts of SolidWorks, so you can always refer to them. And I hope this kind of helped you go over like the brief functions of the SolidWorks, and then I hope it was helpful and then can get you started.
Thank you, Joseph. That was really eye-opening. I hope this is useful to some of you. And we got time for one or two questions. If there's something you're not quite sure how he did, you want to ask him, go ahead and ask a question.
Joseph, I have a question in regards to manufacturing.
Yes.
So after you create the parts or done your assemblies, and then you're gonna save this file in some sort of format. And on my back, I have a 3D printer that I've been using. And let's say I want to design a part and print out using my 3D printer. Is that possible to use SolidWorks or any other like software that you suggest?
Do you know what kind of format the 3D printer takes in? Like,
I believe it's a OBJ file, like object
OBJ?
file. Mm-hmm.
Okay. In the parts option and also in the assembly version, there's an option to save, and then if you save it, it automatically save it as a SolidWorks assembly. For example, if I try to save it, you can't. I know I saved the two parts here, but it doesn't show up because this is an assembly mode compared to the part mode that I created before. And then if you click on the type, it'll show up all the different types of file that it can save it under. So for example, for me, when I try to convert this into ANSYS, which I want to do airflow simulations, right now it has been updated to accept the SolidWorks assembly model as it is, this file, but before it used to only accept IGS files. So I had to save it as IGS file and then move it over. But I believe there are different options you can save it here as. I don't see the OGS, I think, here.
I think STL file will do
Mhm.
for 2D printer as well.
Yeah, so this, yeah, so if you want to move this design into another system or another software, there are different options. You can save it on there that you can import it as.
I see. Thank you.
That's a good question. But for our students, if they just want to save their drawing and put it into a paper, probably a JPEG would be save it as a JPEG file, and then they can put it into their paper as a figure.
Yes, and I haven't gone over this, but if you go under new, then there's also a drawing option. If you click on this one, this will show up, it'll show up a different kind of format. It'll show up a paper. And then if I click on the, I guess the, for example, part 2, or isometric. There is an option to direct it here. For example, if I click on here, it will show me a front view. Then if I drag it down here, it'll give me a top view. And if I drag it to the right, it'll give you another side view. So, and then it'll also give me an isometric view if I drag it diagonally.
Great.
So there are also ways in the drawing, I didn't go over it, but there are ways to do it in SolidWorks also.
Okay, well, that's about all we have time for. I hope you students can appreciate the value of the ability to draw using computers. I think no matter where you're going to end up working, you're going to need to communicate your ideas to someone, either your boss or to an engineer, someone who's going to manufacture your idea. You're going to need to draw it out for them in a way that's professional and precise and accurate. You're not just going to be able to use a crayon on the back of an envelope. You're going to have to use something that's useful and savable and repeatable. So this is one tool that you have out of many. And so that's why we include MMET 105 in your curriculum. And we want to try to apply that with some of the other drawing tools that are available to you. Okay, well, thank you, Young. Y'all give Joseph a hand. Appreciate that, Joseph. That's great. If you want to get a hold of Joseph, contact him through Young. Otherwise, we're going to have on Tuesday, we're going to have Matthew Whiteacre come in and talk about Fusion through 360. And I'm sure he knows SolidWorks too, so he's a resource for you as someone who's taught you before.